I'm Chris McDermott. I'm the head of engineering for Wallaroo.AI. We're one of the sponsors of the event. We're an MLOps platform, and we have a booth over at booth 301, so I'd love for you to stop by and talk to us. I'll try to mostly avoid making this just a presentation about our software and what we do, and talk more about sort of general challenges and general best practices and recommendations for operationalizing and managing your machine learning models. So this is probably preaching to the choir. I imagine that most of you are sitting in this room because you already believe that AI has the potential to transform your business and to deliver value. But it's worth restating. You know, there are a lot of opportunities to make your business more efficient, to reduce churn and increase customer satisfaction and things like that. It can also help you bring new products to market or open up entirely new markets. You know, it can help you move faster and stay ahead of your competition and outmaneuver your competitors. However, and there is a big however, AI is actually quite hard to integrate into your business and to operationalize. And there are a lot of challenges associated with doing that successfully. According to a Gartner report in 2021, 90% of AI initiatives fail to deliver the expected ROI to the business. 90%. And there are a number of reasons for that. Some of them are probably familiar to you. It's hard to acquire talent. It's hard to build a strong team. It's hard to pick the right tools. It's easy for costs to spiral out of control. It's difficult to scale this stuff. But one of the primary challenges is that an AI initiative is not a one-done project that you can complete and move on from. In fact, the AI and ML pipelines require continuous feeding and caring. And you need to build repeatable processes and really change your business practices around these things and integrate them into your decision making to continue to get value out of it and to drive the expected returns. I want to focus today on computer vision. There are a lot of other cases for AI and ML, including fraud detection and a whole bunch of things, but computer vision is a pretty exciting area at the moment. I think there's a lot of stuff happening there, and a lot of people are finding ways to apply machine learning and computer vision to their businesses, to their business problems. Manufacturing has been an early leader in this space. I think they've been doing quality inspection and defect detection for a long time. But the Internet of Things is unlocking sensors everywhere, and edge hardware throughout smart cities and smart refrigerators and TVs and things. Medical imaging is also coming a long way. And just this week I was reading about further advancements in cancer screening and having CV models detecting with more accuracy than humans. Even things like agriculture, maximizing crop yields, and some surprising use cases there are really solidly within this field, and we're seeing a lot of advancement there. I'd like to talk about two customers that we're working with and that we've helped, and their specific use cases to try to ground this a little bit for you. One of the companies is focused on crosswalk safety, so they're partnering with a major US city, and they are analyzing frames from high-resolution 1080p video from cameras installed in crosswalks. And they're using that to help make judgments and change the lights and try to make the environment safer for pedestrians. These are complex pipelines. They involve a lot of data. They run at the edge. All of the hardware actually runs on a 5G network, and they need to monitor it continuously. So that's quite a challenge. A lot of throughput, a lot of data. On the other side, we have a company that is in the marketing space, and they're working with their customers to analyze the video, the ads, the commercial TV, the places where those ads are run, and look at demographics and market segmentation and make sure that the marketing strategy is aligned to what the business needs. And again, this is video, tens of millions of video of images and frames that need to be analyzed. It's very high throughput, it's sensitive to latency, and it involves a whole lot of data. As many of you probably know, CV comes with its own set of challenges. On top of all the challenges that you have with ML in general. The three primary challenges are the size and scope of the data, because image files and video files are much, much, much larger than text. And there's a cost to moving that data around and transferring it over networks. But there are also privacy concerns and security concerns. How many copies of the data are you storing? How are you transmitting them from one location to another? How long do you retain them? What are they used for? Who has access to them? All of that stuff can be really tricky to figure out. At the same time, the computer vision models tend to be more computationally intensive and have higher requirements in terms of computing power than a lot of the older models and the linear regression stuff. That can be a challenge. Many of them are accelerated by GPUs, but GPUs are quite expensive, and there are shortages. There are chronic shortages of GPUs pretty much everywhere, and so it can be a real challenge to get your hands on them and then to deploy them and maintain them around all your devices. And then finally, the shape of the data is different, and there's some challenges around observability. If you're dealing with structured text and numbers and integers and things like that, it's a little bit more approachable of a problem, and there are a few more tools out there. But for computer vision, I'd say we're still sort of at the early stages of that journey. So what are your considerations? What should you be thinking about? And what challenges are you likely to run into? One, as I've mentioned a couple of times, is about the data. So where is your data stored? How many copies do you want to keep? How expensive is it to move the data around? And then at the same time, what does your compute look like at the edge where the data is? In many cases, it might be easier to run your models at the edge next to your data and avoid having to move your data. This depends, of course, on what hardware is available and which models and frameworks you're using. They all behave a little bit differently. But you should be benchmarking on different hardware and determining for this specific model and framework, is it actually accelerated by GPUs? Do you need to be running this model in a cloud with GPUs and schlepping all the data there? Or can you run a different model or tune the model slightly differently and use generic x86 hardware at the edge and keep the model and the decision-making close to the data? Something else that may or may not be important to you is the power consumption and the power utilization. For some of this stuff, if you're doing it at scale, that can really add up very quickly. And if your organization has any environmental goals or are committed to reducing their carbon footprint, you may actually be either helping or hindering that effort with some of your choice of your model and the hardware that you run it on. So again, in some cases, you may want to avoid GPUs and run on either x86 hardware or some of the ARM architectures that have ML accelerators built into them. Things like Graviton that's available in AWS or the Ampere chips in Azure and Oracle and other clouds. But again, to my mind, the biggest challenge and the biggest concern that you should be thinking about is how do you make all of this repeatable and automated and efficient? Because you're not going to be doing this once, you're going to be doing this over and over and over again. For every use case, you need to not just train a model, but identify your data, clean your data, prepare it, tag it, enrich it, all of that. You need to not just train one model, but probably train a bunch of models and analyze the differences between them. Look at how they perform on different hardware architectures. Look at the latency, look at the power consumption, look at all these different factors and the accuracy and figure out which one of those works best for you and for this specific use case. Then you need to figure out how to deploy your model, and you need infrastructure around it, you need software engineering around it, you're going to need an API, maybe a UI to put in the hands of the users that are actually going to be using this data. All of that needs to be done not just once per use case, but over and over as new models and new frameworks come out, as the world changes. You're going to have to either retrain those models or deploy new models that are more accurate, have lower latency, or whatever other improvements may come. So those processes and how you deploy those things and how you manage them, they have to be repeatable. They have to be efficient. You cannot, as a business, be reinventing that wheel every time that you have to redeploy a model or deploy a new use case. So just like there's a set of considerations and questions that you should be asking, there are a set of best practices that go along with each of them. So for the challenges of deploying models, build yourself some automation, pick a platform that you can rely on, find a way to make that easy and repeatable. Consider running as much of the analysis near the edge where the data originates and where it lives. Don't schlep the data around. Analyze your pipeline, try to figure out the optimal combinations of models and hardware and all of that, and figure out which factors are most important to your business and matter the most. Consider different architectures, consider ARM, consider GPU, consider x86 and all of that. And then make sure that you have a way to understand your data and your model drift in real time. Observe your models and your pipelines. Don't just deploy them and walk away, because they start to degrade the moment that they're in production, and you are going to need to retrain them. You're going to want to replace them with newer models that become available in the future. So to bring it back to these two specific use cases, Wallaroo, working with these partners, was able to help deploy these complex multi-step pipelines to the edge. We were able to prove that we can infer 3 times faster using Wallaroo on standard x86 hardware. They didn't need GPUs. That, in turn, unblocked a lot of their hardware acquisition and hardware planning costs, and allowed them to move faster and get to market faster. And we also provide a central pane of glass where you can observe all the different pipelines, and that allowed them to manage this all much more efficiently than the other options they were considering. On the marketing side, it was a similar story. So we're helping this customer roll out these pipelines and build these continuous back loops so that the models are constantly being observed. That data is flowing back into the data science group. They're analyzing the results, and they're able to retrain and redeploy. We've been able to prove that we can help them reduce costs by 85% and scaled 10x the use cases, with less time required from their data science group and ML engineering group. So this is a high level of the architecture that we've helped implement for these two particular customers. And I want to talk about it as sort of a general approach to things. The first important piece for us was meeting the data science team where they're at and integrating with the tools that they're already comfortable in. And so for most of our customers and most of the people we engage with, Python and Jupyter Notebooks are kind of the center of the experience. And our SDK imports into that Jupyter Notebook environment and allows them to really kind of move quickly and not have to learn a whole bunch of new stuff in order to be productive. They can train models in SageMaker, in Azure ML, and Vertex, and Databricks, and all of these existing tools. Each of them has their own strengths and weaknesses. They have different kinds of models that they support. There are sort of pros and cons to all of it. And really, from my perspective, I think it's about the flexibility of picking the right tool for the right job and being able to leverage the best of any of these. Once you've trained your model, though, you need to be able to deploy it, and you need to be able to deploy it to a diverse set of devices. And that might be another cloud, it might be an edge device, it could be some sort of embedded device. But ideally, whatever architecture you build, it should be flexible enough to support all of those, and flexible enough to support those pipelines running on GPUs, on x86, on ARM, on all of the available architectures. And then finally, you need the pane of glass in the middle. You need something to orchestrate this and make it all manageable and make it efficient. So the Wallaroo Operations Center provides, I'll show you a little picture here with some screenshots, but charts, dashboards, things like that. You can quickly see all of your pipelines. You can collaborate on them together through workspaces that you invite other users to. You can create baselines that show how the model was performing when you first deployed it, and you can compare those in real time to things that are happening now. You can look through the logs of all of the inference requests and examine both the inputs and the outputs, see when that prediction was made, why it was made the way it was. We also, through our deployment platform, support A/B testing and shadow deploys and an experimentation framework so that you can test out new models with low risk. And so whatever solution you build, it should probably look something like this and include all those capabilities. So how do you scale how do you scale machine learning, and how do you return value to the business? This is the way. And again, Wallaroo is a sponsor. We're at booth 301. We're going to be giving away a dark saber tomorrow afternoon at the end of the conference. So I would encourage you all to stop by. We've got a team of ML experts. We've got a great product. We're happy to talk to you about use cases, answer any questions that you have. I would be happy to share more best practices with you. We're at booth 301, and if you leave a business card or write your name down, we'll put it in a bucket, and tomorrow we'll do a raffle and we'll draw a name, and somebody will go home with a dark saber. So that's all that I've got, but I would love to open the floor up to some questions.